Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying Marine Auxiliary Systems and Deck Machinery. Today we have 11th lecture and the topic is plate type heat exchangers, temperature control and monitoring their performance. In this tutorial, we will first discuss about the construction and assembly of plate type heat exchanger. Then we will discuss about the flow of two liquids between the plates and their sealing arrangement. Next, we will discuss about the construction of plates and sealing between them. Then we will discuss about the cleaning procedure of plate type heat exchangers. Next we will compare the two types of heat exchangers. Then we will learn about the methods of temperature control in coolers. Lastly, we will learn about the monitoring the performance of heat exchanger. Let's discuss these through the following slides. Plate type heat exchangers. The sketch shows the construction and assembly of plate type cooler. Main frame of this cooler consists of a support post which has a carrier bar on the top and a guide bar at the bottom. Frame plate is secured between carrier bar and guide bar either on the front side or rear side. Four branch pipes on the frame plate provide inlet and outlet connections for the two liquids. A pressure plate holds all the components together. A set of plates are sandwiched between frame plate and pressure plate. They are made up of from an identical metal pressings with horizontal or chevron pattern corrugations, each with a nitrile rubber joint. A number of tie bolts and nuts keep the plates pressed up to prevent internal leakage between the liquids or external liquid leakage to the surroundings. The joints are squeezed when the plates are assembled and clamping bolts are tightened. Over tightening can cause damage to the plates, thus, correct procedure should be followed. A torque wrench should be used for tightening and correct stack length should be obtained after tightening. Coolant enters through the bottom connection and leaves from the top. Similarly, hot liquid enters from the top and leaves from the bottom. Sealing arrangement in plate type coolers. The sketch shows the flow of two liquids taking place between the plates and method of sealing between them. We can see that hot liquid enters from the top in alternate plates and flow downwards through the corrugations and leave from the bottom. Similarly, the coolant enters from the bottom and passes through the other set of alternate plates and leaves from the top. Seals are so arranged that one fluid flows in alternate passages between the plates in opposite direction. Flow of liquids through plates. This sketch describes the construction of plates with their sealing arrangement and the flow of liquids through them. The plates are corrugated as shown in the sketch, which make them stiff, which require less thickness. Corrugations additionally increase the surface area. Both the increased surface area and reduced plate thickness improve heat exchange efficiency. Plates are usually made of titanium, which are resistant to corrosion and erosion. Corrugations promote turbulence in the flow of both liquids and encourage efficient heat transfer. As opposed to smooth flow, turbulence causes more liquid to pass between the plates and come in contact with them. Turbulence also breaks down the boundary layer of the liquid, due to which it tends to adhere to the metal and act as a heat barrier as in case of laminar flow. Excessive turbulence can result in erosion of the plate material, which is avoided by using moderate flow rates. Counterflow of the two liquids arranged between the plates further improves the heat transfer. The nitrile rubber seals are bonded to the plates by suitable adhesives. Removal is facilitated by application of liquid nitrogen, which makes the seal material brittle and can be broken. Seals allow the two liquids to pass through in alternate plates without intermixing. Nitrile rubber is suitable for temperature up to about 110 degrees centigrade. At higher temperatures, the rubber hardens and loses its elasticity. Telltale holes provided in the seals prevent intermixing of the two liquids and reveal the damage to the seal by external leakage of the liquid. Cleaning procedure from plate type heat exchanger. Following procedure is generally adopted for cleaning the plate type heat exchanger when its performance drops. Isolating the heat exchanger. Heat exchanger is isolated by closing both inlet and outlet valves for both liquids. Draining the liquids from heat exchanger. Vents of both liquids are opened and contents are suitably drained. Measuring distance between tie bolts. Measure and record the distance between the tie bolts. Dismantle the heat exchanger. Remove the tie bolts. Move the pressure plate towards support post to create gap for cleaning and inspection. Cleaning the plates. Clean the plates on both sides by soft brush and water. Inspect seals. Pay special attention to the seals and look for any damage. Assemble the heat exchanger. Assemble the heat exchanger by tensioning the tie bolts to the original measurement. Test the heat exchanger. Close the drains for both liquids and start their flow one by one while purging the air. If no leakage is observed, the heat exchanger is ready for use. Comparison of plate type and shell and tube type heat exchanger. We will compare the two types of heat exchangers on the following basis. Efficiency. The major advantage of plate type coolers over the tube type coolers is their higher efficiency. Size. Higher efficiency of the plate type coolers is reflected in a smaller size as compared to shell and tube type coolers for the same cooling capacity. Suitability. Plate type heat exchangers are not suitable for pressures above 20 bar and temperature above 110 degrees centigrade, although shell and tube type heat exchangers are suitable. Plate type heat exchangers are generally used for liquids as in coolers, whereas shell and tube type heat exchangers can be used for both vapors and liquids as in coolers, condensers and heaters. Ease of maintenance. Plate type heat exchangers are easily opened and cleaned as compared to shell and tube type, which also require free space equal to the tube length on one side for their cleaning. Finding internal leakage. It is easy to detect internal leakage in shell and tube type heat exchangers as compared to the plate type cooler when a leakage develops. The plates must be visually examined to detect the fault. The joint between them can present problem in service or after maintenance. Repairing the leak. A plate type heat exchanger can be quickly repaired either by removing the defective gasket or exchanging a set of defective plates with spare ones. Whereas shell and tube type heat exchanger require plugging of the tube. If spare plates or gaskets are not available, heat exchanger can still be operated by removing the defective plates set with reduced plate, stack length and reduced capacity. Cost. Plate type heat exchangers are expensive as compared to shell and tube type due to use of titanium plates. Advantages such as compact size, ease of cleaning and better efficiency outweigh their initial higher cost. Temperature control in coolers. The temperature of the processed liquid can be controlled by the following ways. By controlling the flow of coolant. In this method, full flow of processed liquid takes place and the temperature control is achieved by regulating the flow of coolant. Direct cooling by seawater. In the earlier times, process liquids were directly cooled by seawater and the temperatures were maintained by regulating the flow of seawater. Cooling by low temperature fresh water. For reducing the corrosion of seawater pipes and water boxes of the coolers by seawater, modern ships use low temperature fresh water to take away the heat from various process liquids. This arrangement makes the seawater system very short and reduces cooler's cleaning frequency greatly. Modern method of seawater control in SD coolers. In modern systems, the flow of seawater through the low temperature freshwater cooler may be controlled by varying the RPM of seawater pump, which is also helpful in reducing its power requirement and improving the ship's energy efficiency. By controlling the flow of process liquid. In this method, coolant flows fully and the temperature of the process liquid is controlled by regulating its flow. The usual method. Usual method to control the temperature of process liquid in a cooler is to regulate the flow of liquid through a three-way valve such that part of the liquid is passed to the cooler and remaining gets bypassed, which joins back at the cooler outlet. Three-way valve operation. The three-way valve is operated by a temperature controller which measures the outlet temperature of the process liquid and compares it with the set point to position the valve correctly. The position of three-way valve provides valuable information about the condition of cooler and its reserve capacity, which is useful tool in planning the maintenance of cooler. Manual method. In the absence of controller, a bypass valve is provided between cooler inlet and outlet of the process liquid. Inlet and outlet valves are kept full open and the control is achieved by operation of bypass valve. Trying to control the temperature by regulating the inlet valve while bypass valve is closed will result in reduction of the flow to the machinery causing high temperature. Performance of heat exchangers. Performance of a heat exchanger is judged by the outlet temperature, whether it is able to maintain the desired temperature or not. Venting of heat exchangers. Venting of a heat exchanger is most essential for its performance. Vertical shell and tube type heat exchanger. Vertical mounting of single pass coolers will ensure automatic venting. Although this arrangement is good, but it is rarely seen in practice on the ships. Horizontal shell and tube type heat exchangers. Cooling water inlet from the bottom and outlet from the top, particularly in multi-pass arrangement, achieves automatic venting with horizontally mounted shell and tube type heat exchangers. Air vents in heat exchangers. Small amount of air trapped in the upper part of the shell and water boxes should be removed from the air vents, specially equipped for this purpose. Coolant temperature difference. Usual temperature difference between inlet and outlet of the coolant should be about 5 to 6 degrees centigrade, which is able to indicate whether the performance of heat exchanger is satisfactory or not. Position of three-way valve. As discussed above, the position of the control valve clearly indicates performance of heat exchanger. When the control valve bypasses some of the process liquid, it indicates that performance is satisfactory so far. Otherwise, heat exchanger requires maintenance. Recovering drop in performance. Drop in performance of heat exchanger can be recovered by cleaning the heat exchanger heat transfer surfaces mechanically or chemically. To facilitate maintenance of coolers, drain plugs or valves are fitted at the lowest point in both types. Air is admitted through vent for draining the cooler completely. This completes the study of plate type coolers, comparison between the two types, method of temperature control, and measuring heat exchangers' performance. This book is written by me and covers all the topics as per the syllabus specified by Indian Maritime University. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. The book can help the students in preparing for the exam and also to work on ship auxiliary systems and deck machinery safely. Hope that you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I'll be back with a new lecture shortly. Thanks for watching till the end.